So after I start the recording, I can come over here. I've got to turn that on. Okay. Desktop screen share. This small. They're very funny, hold on. Okay, anyway. I'm going to start up another window here. We're going to get into all of the next level of state machine stuff. So if I go SMACH ROS tutorials and open that up, we can open up the SMACH tutorials again. And then, so last time we went through all of the classes and everything, and then we finally got through this simple state machine. So we were able to get through the first one. And to be honest, the rest of these are all pretty self-explanatory. Like after you click on the simple one, if you guys remember, we had the foo, the bar, and it had the outcomes, and then the final exit, right? And if you click on user data passing, and you look at the graph, you have foo and bar, and it's the same exact thing. There's the only difference is in the code that you have these input keys and these output keys. And then like nesting state machines, you come into here and you look and you have this foo and bar and it does the same thing. All the difference is that it has this other state on the outside of it, and it makes this, like it puts a box around this one basically. And then same with the other ones, they're all pretty self-explanatory. And then if you don't get anything on this side, you can view them over here. So like if you don't understand what's going on over here, you can click on the passing user data between states one. And if you click on this, it'll come in and it'll tell you input keys does this and output keys does this, and it'll basically like explain everything on this half of it. But even with all of that, I'll still go through this number 2 and number 3 just right now, just to get you guys finished with all like prereq knowledge. Concurrent state machines we never really use in our applications, both for RoboSub and for ASME. So we never have two states running at the same time. That's what the concurrent one is. And the simple action state ROS one, we've never really had a need to use. I don't think we'll be using it. It may come up at some point, but so it might be nice to go through to know, but it's not really important for now to start programming the state machine stuff. So after we did the simple, these two are the two next ones that we'll actually be using. Yeah, so if I open up another terminal, and if Zoom lets me, I'll try to grab it. There we go, got it, okay. Okay. Then let's see, where are we at? Okay, so I can go into here. I think I did it in the RoboSub folder, in the state machines folder, in the workshop 7. Yeah, okay. So if you remember from last time, we made this example.py, and it was all about classes and how things can like depend on other things and everything like that. So we went through that. This is just to refresh everybody's memory real quick. And then our first smash.py was adding in the states and going through all of that init and execute stuff, and adding in all the init and executes and the states and then everything like that. And today we're gonna be doing kind of the same thing. It's just gonna add a couple things on top of it. So I think I'll go here and I'll make another directory, and I'll name this one workshop 8. And we could do it line by line. Might as well, yeah. Yeah, it doesn't matter. Yeah, might as well. Okay, so we'll go into workshop 8. Yeah, okay. So let me get rid of that. All right, so now we're in workshop 8 over here, and we can open up user data passing, and we can start off with all of this stuff. So I could type up every line. It might be going slower. I'd have to delete this. I think it's probably faster to type than to copy paste. Let's see. So we can call this one. Let's see. It's about user data passing, so we can call it like user data smash or something. User data smash.py, and then it's a Python file, so make sure you throw that .py at the end, and then we can get started with every ROS Python file. Remember, you always have to throw in this first line so it knows that it's a Python file. Then you import your ROS lib, and you don't want to add in that second part. So same thing with before, you import everything. A lot of this is going to be like familiar from last time. It's just like kind of doing the same thing, is import all of those guys. And then you start defining your classes, and things are going to be different in a second here. So we start up the class, I'm naming it foo, and it's a smash state. And then we want to define init self. So in the initialization part of it, we're saying smash.state.init. And if I open up another terminal, there we go, got it. If I open up another terminal and I go into workshop 7 and I look at the other one that we made, so far it's the exact same. So we did Python, ROS lib, ROS py, smash, smash ROS, foo, init, and then right here is where the difference is going to come in. So I'm going to keep this open like down here, and I'm going to type up the next line that it wants me to type. So it wants me to go self, comma, outcomes equals. So it wants outcome 1 and outcome 2. If we remember from last time, outcome 1 goes to bar, and outcome 2 like finishes the code. So I'm going to rename outcome 1 to continue. And then outcome 2, since it goes out to the exit, it goes to the finish, we'll just name this like exit. And if I can get that back. Yeah, so far it's the same thing, right? So we had outcomes, continue and exit. And then we close that. And before we would do this and just end it. But now we're going to be dealing with user data. So user data is basically, bring that back. User data is basically data that you can pass through different states. So you can have, for instance, like if one state can happen multiple different times. So for instance, the waypoint navigation state, you could do waypoint navigation multiple different times in the code. And waypoint is when like you have, when there's no lanes anymore and you want to use the GPS and go from a certain point to a certain point, you would use waypoint navigation. But you could go to that multiple times. And what you could do with user data is every time you go to it, you could tell it, this is my set point. Like this is my latitude and longitude that I want to go to. And basically, if you tell it, if you want to tell it that, you would do that with these user data things. So you can pass it, you can pass that information into the state. And yeah, so I'll go with their formatting right now. See, if I could add it in here, but if I do that, it's just going to go off the page. So I could make this guy larger, and maybe I can fit the input one into here. Input key, I can't fit that there for sure. Okay. Yeah, Python isn't like Arduino, so you can go to different lines and it won't really care. Arduino sometimes gets a little mad if you try to do something like this. But let's see. So we have foo counter in. So that's the input key, foo counter in, and we'll deal with that. We'll deal with that in a second. I'll show you guys at the bottom what that's going to be. And then output key is foo counter out. Okay. So our outcome is the same. It's either going to be continue or exit. And if you guys remember, continue goes to bar and exit just exits the state machine, right? But now we have these two keys. We have the input key and the output key. And if we scroll down here, we can see in this remapping all the way at the bottom. So like whenever we did state machine.add and we added foo and we put in all the transitions, there's a new one called remapping. And what this does is it'll basically take state machine counter, so SM counter, and it'll put that into foo counter in. So every time we go to foo, it's gonna automatically have this foo counter in, and whatever SM counter's value is, that's gonna be the value for foo counter in. But then you also have a foo counter out, and you're saying that that is set to SM counter. So basically what's happening is SM counter is coming in and it's giving its number to counter in, and then counter in gives that to counter out. Counter out decides to do something with it, like maybe we add 1 to it. So like SM counter starts up at 0 and it says foo counter in is 0. Then we can add 1 to it and say that that's foo counter out. So now foo counter out is equal to 1. And then you say state machine counter equals 1. So then next time you come back into foo, my counter is 1, and then this gets set to 1. And then you add 1 to it, and it's 2, and then now it's a 2, and then it comes back in, and it's a 2, that's a 2, that's a 3, and it just goes like that. So if we come back to here, we did that, so we just set that up. All we did was that's just the initialization. And then now we can go into the execute part of it. So you have self, comma, user data. And this time we'll actually be using this user data. The last time we ignored it, this time we'll actually be using it. So then we have rosspy.loginfo, same thing as always. We'll rename it to running foo instead of executing state. So we're going to be running foo whenever this prints. Oh, sorry, somebody was trying to join. Okay. Yeah, Richard, if you can, I'm not sure if you're able to let people from the waiting room in because it's hard for me to pay attention at the same time. Yeah, okay. So we have rosspy.loginfo, we're running foo. So basically every time we execute foo, it'll print that out. And then we want to say if we check last time, we said if self.counter is less than 3, do this, right? And over here we said self.counter is equal to 0. Now we're saying, I'm trying to keep this open, there we go. Now we're saying if user data dot foo counter in is less than 3. So instead of self.counter in, it's user data dot foo counter in. So if user data dot foo counter in is less than 3. So you remember last time we were using this self, now we're using this user data. And user data is going to be passed between like all of the states now. And we want to access the foo counter in part of it. So we put the dot foo counter in. And we say if that counter in is less than 3, then do user data dot foo counter out equals user data dot foo counter in +1. And the reason all these names are so long and complicated for no reason is just because we're also going to be doing this in the bar state, and we just want to keep track. So we want to know that this one is for foo and it's a counter and it's out, but this one is in and it's also for foo, and you just want to keep track of all that. So you probably have to get used to having a bunch of long names for no reason. But yeah, so if the counter is less than 3, set out equal to the counter +1. So like it comes in as 0, and 0 is less than 3. Then you plug in 0 to this equation, 0 plus 1, foo counter out is going to be 1. And then you want to return continue, right? Because our outcome is either continue or exit. Since it was less than 3, we want to continue. And then we want to say else. The only other else is that it's equal to 3, right? Because it's going to be, if it's less than 3, then continue. And if it's equal to 3, then return exit. So if it's equal to 3, then we're going to exit, okay? And then that's all there is in the foo. It's literally just if it's less than 3, add 1 and continue. And then if it's equal to 3, we're going to exit. And then that's all there is to that. And I'll just move this up, I guess, yeah. And then we can move on to bar smash.state. We got half hour, okay. Yeah, this one should be relatively short. Should be able to get this done pretty quickly. If I'm rushing through it, please ask questions. I'm just trying to, I think it's pretty self-explanatory, so I'm going through it kind of quickly. So same thing as before, we have all of this. So smash.state.init self comma outcomes. We remember the only outcome that we had was to go back to foo, right? Because bar, the only arrow that it has is this one right here, and that takes you back to foo. So instead of being weird and putting outcome 1 for no reason, I'm gonna name mine back to foo, because that makes a lot more sense to me. And then now we have an input key. And the input key for this guy is going to be whatever the output is of this guy. So he is going to so foo here is going to output a number, and we're going to pass that to bar. Bar is going to basically like log the number and go back to foo. And then it's going to pass that data into foo. And I'll show you guys what's going on here in a second. So so far we have the same thing as before, but now we're going to add in that input key, which is going to be bar counter in. Yes, it fit perfectly. Nice. Yeah, okay. So then that's all you have in the initialization is just set up the smash state. And same with before, is set up the smash state. This one looks more complicated, but it's really just one line. And then define, execute, self comma user data. Yeah, okay, self comma user data, and then I can scroll this one down for you guys too. And over here, we have all we're doing with it. So this part, it's a little bit weird. All we're doing with this state is we're literally just logging the information. So Ross Pi I'll just write it out, whatever. ROSPy.loginfo. And since we're in bars execute, I want to say running bar. And then ROSPy.loginfo. And it wants me to just log what the counter is at. And I could do it their way. I could do it a different way. It doesn't really matter. I could just write user data dot bar counter in. It's annoying me a little bit. There you go. Yeah, so then this will log info that you're running bar, and immediately after that, it'll say user data dot bar counter in. So it'll print out the number that we're at. So if we start off at 0 and it adds 1 to it, the first time we come in and it says running bar, we should see a 1 underneath it. So we should see a 1, a 2, and then we shouldn't see a 3 because it should exit at 3. So let's see if that's right. Oh, and then you also need to return back to foo, right? Because that's your only outcome. You gotta make sure to add that in anyway. So after we run our code, we're gonna go back to foo. And that's all there is to those two states. It's just foo and bar. And I'll go over here and I'll go same thing as before, like define my loop. And my loop is gonna be a rospy.init node. You can name the node whatever you want again. I'll just name it like our second, let's just name it smash. Our second smash. And then you can throw in here, I'll probably just copy my same formatting as last time. So my state machine is equal to smash dot state machine. And the outcome of the state machine, they want you to put here that the outcome is outcome 4, and that's this one here. But I really don't like that naming style, so I'm going to say that the outcome is right here, is finished. So my final outcome of my state machine is that it's finished. That makes a lot more sense to me, so I'm going to go for that. You guys can name these stuff whatever you want. Just make sure you put the names in correctly whenever you add in the state machine down here. Yeah, okay, so then that's all there is to that. And now the only thing that's really different here is this line right here. So I have a foo counter in, I have a foo counter out. Oh, I also missed that right there. There. So I have a foo counter in, I have a foo counter out, and I have this bar counter in. But for all of them to communicate with each other and like equal each other, I need to initialize like a global variable. So all of these are like local ones. So foo counter in and foo counter out, those are part of foo. And bar counter in, that's a part of bar. But you need one like global variable that looks at everybody and can talk and can basically like hold the data to pass between the states. And that's going to be called my state machine. So my sm dot user data dot, and then you can put in the name of it here. So they want to name it SM counter. That's actually a decent name, state machine counter. Let's just go for their naming. I like that one. So state machine counter, you can name this whatever you want, obviously. You just have to rename it over here. So my state machine dot user data dot state machine counter is equal to 0. And then same thing as before now, we say my state machine. Oops, smash dot state machine dot add. And the reason I'm writing this one out is because I changed a lot of the names. So I'm gonna be deleting a bunch of stuff anyway. So we named it foo. So we put foo into here, and then you can name this one whatever you want, but I'm just gonna leave it as foo because that's simple. And then we're gonna say how it transitions. And just the same thing as before, it's going to transition. Let's go up here. It's going to transition from foo to bar through this one here. And I named this one continue. So it's going to transition from continue to bar. And it's also going to transition from exit. So this one over here, this one is called exit. And it goes to outcome 4, which I named finished. And let me see, how do you put the brackets at the end here? You go like this, and you throw a comma at the end. Okay. So let me put this on another line because it's not fitting. Yeah, we'll do that. Okay. So it transitions from continue to bar and from exit to finished. And then that's all the transitions that it has. But it also has this remapping. And that remapping, let's put a space there. That remapping is the one that's going to remap all of this counter information. So it's going to say that my foo counter in gets its data from user data dot state machine counter. So it gets its data from state machine counter. And I probably should have organized this the way that they organized theirs, but it doesn't matter. And I'll go over here and I'll say that foo counter out. So foo counter in gets its number from state machine counter, and foo counter out prints its number to state machine counter as well. And we'll close all of that, and then that's all you need for the first foo state. And then fix that. Okay. Okay, there we go. And then we can go smash dot state machine dot add. I guess I didn't change the names for these, huh? Whoops. I guess I could just copy paste it. Whatever. So we're going to add in bar really quickly, and we're going to say that this is the bar loop up there, and it's going to have its only transition is going to be to go back to foo, and you said that that takes you to foo. Okay, and then that's all there is for transitions. I'm just following along right here. That's all there is for transitions, but then you also have a remapping. And I don't know if you really need to do this. It might work without doing this, but I'm going to add it in anyway. So what's going on is when the state machine starts, it's starting off with state machine counter equals 0. Then it comes into foo, and foo counter in is set equal to state machine counter. So it's foo counter in is set equal to 0, and it comes into here. It's less than 3. So foo counter out is equal to 1 now, and it returns continue, so it goes to bar. But when it goes to bar, foo counter out gets put into state machine counter. So now state machine counter is 1, and you go into bar, into the execute, and you log bar counter in, and bar counter in is about to be set equal to the counter. So we're going to log 1, and then we're going to go back to foo. And since state machine counter is 1 now, foo counter in is going to be 1. And then we'll go like that and so on. Yeah, so we'll go like that and so on and so forth. Yeah. And let me just finish up this code so I can actually show you guys that works. Bar counter in. I hope that makes sense. Just tell me if you're confused. I think it's pretty self-explanatory on its own anyway. Yeah, okay. So then we did all of that. And how did I do my naming last time? Did I do the same thing? Yeah, I just did the same thing. So then I said outcome is equal to my state machine dot execute. So you put your state machine into the very end after you add everything in and you say execute it. And then you do your whole Python stuff of if name is equal to main, then it's too early in the morning. I'm messing everybody up. If name is equal to main, then run my loop, right? And then my loop is this guy right here. So if name is equal to main, then run my loop. And if I save this, it would work perfectly fine. But I also want to show you guys in SMACH viewer. So what I'm going to do is I'm going to add in these 4 lines around outcome. So I'm going to come right here. I'm actually, can I copy paste this? I don't know if I can. Oh, I can, cool. Yeah, so then I'll just delete this line right here. Yeah, there we go, okay. So I just copy pasted the lines over here because it's the same. So the name of this one doesn't matter. The name of my state machine is my state machine, my underscore SM. And then, oh, this line got messed up here. And then over here, you can name it whatever you want. What did I name it over here? I named it just Aren state machine. I'll just name this one, just to be simpler, I'll name this one Aren SMACH. And then we'll close that. So sys.start, outcome is my state machine.execute. Check if I press Control C, and then sys.stop after I press Control C. Yeah, okay. So everything looks good now. I'm going to save it, and I'll exit this one. Gonna need ROS core running. Okay, that's working, and then I'm gonna need ROS run SMACH viewer SMACH viewer.py. That should open up this guy right here. Okay. And then now that this is open, there's no path yet because I haven't run it. But if I do ls, we have user data underscore smash.py. And if I do Python user data, this, it runs through it. And if you look at this, it said running foo, transitioning from continue to bar, running bar, and it printed 1. And then transitioning from bar back to foo, running foo, from foo back to bar, running bar, and now it's 2. And like that, and then 3, and then went back to foo, running foo. It realized that 3 is not less than 3, so it went from foo to exit to finished. And then visual-wise, it looks the exact same as the other one that we did, because in the visuals, it doesn't keep track of user data. But it's the same thing as last time. So you have the foo, it goes continue here, back to foo, and all that. Yeah, so that was all there was to that. And then I'll press quit right here. And yeah, let's see if I can grab this. I'll close that. And then over here, I do Control C. And it does, this is what rospy.spin is checking for when you press Control C. And it closes everything down. Yeah, okay. So then that's all there is in user data, really. I think it's pretty self-explanatory. If we want to use it, we make this global variable right here, and then we can map everything to it, and we can pass information around between states and things like that. Yeah, that's really all there is to that. For both RoboSub and ASME, I can go more in depth. On how we'll be using it specifically. And to clarify, is counter in a user input? Add to perform SMACH viewer. Anything you have to add to perform SMACH viewer? So if you want to use SMACH viewer, you need to have these 4 lines at the bottom. So sys.start So this sys equals sys dot start, rospy dot spin, and sys dot stop. They need to be in that order around the outcome. And I don't remember if I had to download it. I think I did. I think downloading Smash Viewer was a bit of a hassle. I remember there was a lot of random, like, different errors that would come up. I'm not sure. Yeah, I'm sure if you Google like how to download Smash Viewer, if you don't have it already, you can probably just find that somewhere pretty quickly. Yeah. But other than that, code-wise, it's just adding those 4 lines and you're done. Yeah, like me, if you notice, every time I run Smash Viewer, it actually gives me a few random errors here, like GTK warning, negative content height, and version 2.8 isn't installed. Use this, but I have this, so it wants that. Like, it's weird. I've tried Googling some of these errors to get rid of them, but I don't think I found anything. Huh. Oh, that's weird. My Zoom froze. Give me 1 second to reconnect. Okay, there we go. We're back. Nice. Okay. Let me share my desktop again. Let me make this smaller and throw that up here. Okay. All right, cool. So everything should be working again, I hope. Yeah, so anything you need to add is just that. And then to clarify, is counter in a user input? So counter in, it's called user data, but in reality, this could also be something that the states pass to each other. So like if you're, for example, like the IMU, if the IMU gives you a certain angle, you could pass that angle from one state machine, like one state to another state. So it doesn't have to be a number that you type in like before the competition or something. But we don't really use user data too much. There's a few certain instances that we use it. Like with that waypoint navigation, that's definitely an instance that we'll use it. But for the RoboSub side, so far we haven't seen a need for it, but I'm sure at some point while we're programming, something will come up. We'll be like, oh, why don't we just do that with user data? It'll be simpler, and we'll get that done. Yeah. Yeah. Okay. Cool. So then that's all there is to that. That's all there is to the user data one. I should probably speed it up a little bit. Yeah. So let me close this and close this. Yeah, so then that's all there is to number 2. And then number 3, really all it's doing is it's taking this state machine, so that exact one that we just made. So think of this sub right here as like Aren SMACH, and then foo bar, this is continue, that's exit and everything like that. It's taking that and it's making it into like a sub state machine. And the reason this is kind of nice is, like, for instance, for ASME, if you're doing the avoid like a barrel state, that's actually a bunch of different things that you have to do, right? So like you have to like line up with the barrel, and then you have to figure out what angle you're gonna go to, and then turn to that angle and then go around it and do like some nice maneuver. And those all could be multiple different states, but you can group all of that together and just call it like avoid barrel. So like instead of sub, you could call this like avoid barrel. and it could be a bunch of different states in there that just avoid, it's just specifically for avoiding the barrel. And like for a RoboSub, for instance, if we have to go through the gate, so that's like the first task we have to complete, is going through the gate underwater. You might have one state that's like look for the gate, and then the next state that's line up with the gate after we see it, and then the next state that's like go full speed through the gate and like do like a spin or something afterwards to get extra points. But all of that could go under one main like gate submachine or state machine or something. And this one's a little bit longer. I think I'll just copy paste a lot of this one in. So if I go nano, which time we got 5 minutes? Yeah, okay. So if I go nano nested smash.py, and I just grab, yeah, so if you click toggle line numbers, you're able to copy paste stuff. If you don't, it'll try to get the numbers with it. Yeah, so we'll go here and I'll grab all of this, and then I'll come back up here and I'll just do some fixing. So I'll delete that, and then I'll come here and I'll delete that. And then in the init, we'll come over here, and instead of outcome 2, this is the one, outcome 2 is the one that goes out. So this is the one that goes to, this is the exit one. And then outcome 1 is the one that goes to bar. So we'll name that continue. This is doing self.counter. You could actually combine this one and the last one. So instead of self.counter, you could do user data, but I'm not going to do that right now. So instead of executing, I'm going to name this to running. And then instead of outcome 1, we have continue. And instead of outcome 2, we have exit. And then delete those 2 lines. Instead of outcome 1, you have back to foo. And here you have running. And then over here you have return back to foo. And this is all exactly like what we covered before. It's all the exact same code. It's just continue and exit. This is the same exact mini state machine that we had. So from foo to bar, back to foo to exit. And the code is the exact same. I'm going to scroll down. One mini thing you guys could do is you could change the counter to that foo counter in stuff that we were doing in the last one. But I'm not going to do that right now. I'm just going to continue on. So now we have something new. And I'm running kind of low on time, so I think I'll just copy paste this one in. And what's going on here is it's basically just a completely normal state. You have another state, it's called boss or bass or whatever. You can name this anything you like. I could even, maybe I shouldn't. I'll name it Rn, why not? Let's name this one like Rn, right? And then outcome, let me change this one here to running right now, running Rn. Yeah, so basically what this state is doing, it has the outcome of outcome 3, which I really don't like at all. Let me name this like start. So we have this guy up here. It's like the first state, and its outcome is start. And start brings you into here. And then you go from there, you go into foo. And then you run this, and it exits to here. And then from here, it exits to here. And then obviously you don't have to exit to finished. After you exit from this state machine, you could actually move on and continue with other stuff. So like if this was like the gate task, after you exit the gate, you can have a bunch of different options to go to. But I'm going to leave it the way that they have it just because time purposes. It's probably faster if I copy paste and then just delete stuff after. So let's run through this real quick. This one should be my loop. Gonna delete random lines that just take up space. And then I'll delete their comments as well. Yeah, so Control Shift K lets you delete a line, by the way, just in case anybody wants to do that. Yeah, the one reason I don't like Nano, actually Gonzo recently showed me this application down here called Visual Studio Code, and it's actually really nice. It lets you edit code and do a bunch of stuff in there, and it shows you like your whole workspace and everything. It's a great thing to get. I highly recommend getting that. Yeah, I just got it like yesterday, so I haven't messed around with it much, but it seems pretty self-explanatory. It's pretty simple. Yeah. So here I'll rename this to our third smash. Yeah, and then I'll kind of leave their naming the way that they have it. So here they have, I'll go through it over here. Here they made a state machine underscore top, and it says that it has the outcome of outcome 5. So that means like the higher level state machine here, this one up here and down here, it has the outcome of outcome 5, and that outcome 5 is the one that like actually ends the code. And then you have in state machine top, add in this state, the boss state, and I renamed mine to Rn, right? But theirs is called boss or bass or whatever. I'll call it boss. So this boss state, that's the only state. If you see, that's the only state in the bigger state machine, and it transitions. The boss state transitions from outcome 3 to sub, to this capital sub. So from outcome 3, so I named mine, instead of outcome 3, I named mine start. So from start, go to sub. And then it says down here, so that's outcome 3 to sub, right? And then we'll deal with sub down all the way down here in a minute. But after that, you kind of do the same exact thing as up here, but you do it like inside of this state machine top one. So this one is called state machine top. It has the higher level one in it. This state machine sub is the one that's going to have foo and bar and everything like that in it. So you add in foo and bar just like normal, and you add it to this sub one, and then you add it in as a state to the top one. And I'll show you guys like what this means right here. So state machine top is a state machine with outcome of outcome 5. And then you add in the state of boss, like smash.statemachine.add, right? You add in boss. And if you follow this line right here, the only other thing it adds in is statemachine.add sub, which is sm underscore sub. So basically sm underscore sub combines foo and bar. Right here, it combines foo and bar and it puts it into sub. And then in top's eyes, all that's happening is that it's going from boss to sub, and then it's transitioning from outcome 4 to outcome 5. And let me actually rename this stuff. Sorry for going a little bit over time. I'll be done in a second here. So let me just make sure the names are right. So we have outcome 5, which is let's name this one really really finished, because this is the one that actually finishes it. And then you have boss, which I named to Rn, and then the loop is called Rn. And the outcome is to go from start to sub. And then you have, and then over here, you're initializing the sub state machine. And if you guys remember from nano user data, if you guys remember from this one, we named this outcome as finished. So I'm going to put this one here as finished. And then everything else is, I'll close this here. I should have, whatever. And then you have finished, and then you have foo, you're adding in foo. Instead of outcome 1, we have the outcome of continue, right? And that goes to bar. And then instead of outcome 2, you have the outcome of exit and exit. And whenever you go for exit and foo, it should go to this finished. I know this is kind of like probably complicated to keep track of while you're watching, but if you guys do this yourself and change the variable names, that's one thing I definitely recommend is if you're doing this yourself, change the variable names and try to, so that gives you like a better understanding of like, okay, so outcome 1 was this, but I renamed it to this. And it gives you like, gives your brain a little bit of getting used to like seeing which one goes where. Yeah, but then bar has the outcome of back to foo, and it goes to foo. And then we're making that stuff go into SM underscore sub. And then we add in sub SM underscore sub, and we say that it transitions. I could just make this a lot easier looking. Let's say it transitions. Whoops. Like that. Oh, okay, we're good. And then this one transitions like that. Okay. Yeah, that might be a lot easier looking, right? And then I'll go up here and I'll delete all of that. Oh, this probably makes it so much simpler for you guys, huh? Okay, so I'm just gonna go through it one last time and then we're finished basically. We have this top state machine. Its outcome is really finished. So that's this really finished down here. And then in top, we're adding in this Rn loop and it transitions from start to sub. So this Rn, sorry, not loop, Rn state, and it transitions from start to sub. And then we're starting up sub state machine and its outcome is finished. And that's this finished here. And then in that sub state machine, we're gonna have foo and bar. And we know how they work already, right? And then we're gonna add in the sub state machine and its transition is right here. It transitions from finished to really finished. So this one was finished and this one was really finished. So it's going to transition from finished to really finished. And the rest is all good. And then we're going to execute state machine underscore top. State machine underscore top, sorry. And then I just need to add in the line so that we can view it. So I'll go down to the bottom over here and I'll grab these 5 lines right here. So paste like that. Huh. That's weird. Oh, it's because I copy pasted it, huh? All right, so that's a little bit annoying. So I'm gonna come here and I'm gonna go 1, 2, 3. and come back to here. Looks like 4 actually. Maybe I might be wrong with that, but whatever. Just so everything is lined up and working, and then I'll delete that line. So everything should be good now, except for this line right here. Instead of my state machine, it's called SM_top. And over here, instead of my state machine, it's going to be called SM_top. And the name got cut off again. So we can name this, doesn't matter, let's go. We want to call it, this is nested. Let's just call it nested then. Okay, so unless I missed something somewhere, I think I renamed everything correctly. So let's save this and see if I did that right. Let's go out of here. And then ROS core is already running. So all we have to do is ROS run smash viewer viewer.py, and then over here. Yeah, so this is running and there's nothing there yet. Over here we do ls, and now we have nested smash.py, and we'll go Python nested smash.py. Name my loop is not defined. Okay, so I did miss something. Let's go down. Yeah, I did miss something right here. So I'm trying to run my loop, but I defined this as main. So I just need to rename this one here to my loop. Okay, now let's try that again. Python nested smash. All right, and this time it actually worked. And if we open up this right here and get that to focus, it looks a little bit different from theirs, probably because the names changed and stuff, but we're going from Aren's nested to Aren, start to sub, and then in sub, we have foo, and it goes continue to bar, and then from bar, it goes back to foo, and loops a few times, and then it goes exit to finished, and then from finished to really finished. And then that's all there is to that. And then you can see here, it's kind of just doing the same thing as always. It loops between them a few times, and then it terminates from foo exit to finished, and then from sub finished to really finished. And then that's all there is to that. And control C this, close down this terminal, and close that. Oops. And close that down. Yeah. So that was everything on workshop 8. It was just going through those two. Sorry if it was boring. It was just kind of, I think everything is pretty self-explanatory in there anyway. Let me know if you have any questions though. Are we good? If all that makes sense, that's great, because that means that you guys are ready to actually start with the full state machines. Very informative. Thanks. Yeah, you can hack NASA with these state machines, yeah. Yeah, but yeah, so now that we have that done, we can start working on, for like RoboSub, we can start working on these guys. So like starting to think about the competition and breaking down like what are the different states we could have. So like for on the RoboSub side, you have like, okay, so we need to look for the gate. We need to look for a buoy to hit. We need to we need to look we need to look for this and that, and then if we find those, what happens if we find those, and then you like split that off. And like for ASME, you have a different, it's a little bit different on the state machine side. So like you have look for the lane, and then if I see the lane, let's turn. So like we're kind of like going parallel with the lanes, so like we're in between. And like that's another one, is make sure we're in between the lane. And then if a barrel comes up, we'll go to like the avoid barrel one. If something else comes up, we go to this. Just starting to think about like what could happen, what are all of the different things that could happen while you're out there. Yeah, but that's all there was to that. If there's no questions, I'll stop sharing and I'll end the recording as well. We're good?
Yeah. Seems like we're pretty good. More good workshop.
Thanks. All right, sounds good. I'll end the meeting then, and then just if anybody's interested, that was the last one for state machines, and then we'll be doing 2 or 3 on computer vision, and we'll be done with all the workshops.